Hello, and thank you for joining this Introduction to Container Services Manager for Pivotal Platform, or KSM. In this demo, we will go over how KSM can take services deployed on Kubernetes and make them seamlessly and securely available in the Pivotal Platform. If you're looking to bring additional services to your Pivotal Platform, whether they be open source, commodity off the shelf from a vendor, or even internally developed, this video will show you how to get started. Also, just a heads up that at the time of this recording, KSM is currently in beta, but this is still a great time to go try it out. Now, when it comes to application developers using services on the Pivotal Platform, they are used to being able to spin up their own instances on demand to accelerate application delivery. But what if the application they are working on needs a service that is not currently available on the marketplace? Well, in most cases, they go to their platform engineering team and request the new service. Now, platform engineers have a lot to consider when making new services available to application developers. Maybe there is just not enough demand right now within the organization to justify the time needed to manage another service. Maybe they are just too busy right now to field this request. Or maybe the service just isn't available on the Pivotal network. Now, KSM isn't going to solve all of these issues, but it does give the platform engineering team a powerful new tool in their toolbox to fulfill these types of requests in a different way. Let's dive in and see what we're talking about. So here we have our platform operator, our developer, and our PaaS platform. Hopefully this looks pretty familiar. Let's add KSM along with a PKS Kubernetes cluster. Now, PKS is installed as a tile on PaaS, and PKS is a wholly separate cluster without any direct linkage to the PaaS platform. To make services available using KSM, first that service needs to be packaged using Helm. Now, for vendor-provided or open source services, they may be already prepackaged from their source. But for other services, such as those built internally, this may be an additional step. For services which are made of multiple Helm charts, such as the ones we will see in our demo, we will further have to define a ksm.yaml file to tell KSM some metadata about each chart. But once those services are packaged, the platform engineer uses the local KSM CLI tool to make the services available in the CF marketplace. Now from here, from the point of view of the application developer, spinning up a new service instance, nothing has changed. They use the same CF CLI commands they are used to create a dedicated service instance and eventually bind it to their application. But let's take a look at what's happening behind the scenes when that dedicated instance is created. The first thing that happens is the PaaS Cloud Controller is going to notify the local KSM service tile that the request has come in to create an instance of that service. Then, KSM is going to use the Helm charts packaged earlier to deploy a dedicated instance of that service onto the PKS cluster within its own dedicated namespace. Once the service is deployed, KSM then pulls the bind data it needs from that service and stores it securely via CredHub running on PaaS. Then those bind credentials are returned securely back to the application developer. So that's how the system works on a slide. Now let's look at a demo and see how this actually works in practice. So here's our scenario. Our platform engineering team has deemed it necessary to offer rabbitmq as an available service on PaaS to their development team. Now, of course, rabbitmq is available as a PaaS tile, but in this organization, there is a policy that every service needs to have embedded Prometheus monitoring. So starting with the platform engineering point of view, we have requested a rabbitmq plus Prometheus service bundle from our data services team. Let's take a look at that bundle. Here, we see the directory structure of our bundle. We can see two tar.gz files created from running Helm package. The first is the Prometheus monitor, and the second is our rabbitmq bundle. Scrolling up a bit, we can see the KSM YAML file we mentioned earlier, which is necessary in multi-chart deployments like this one. Now, let's look at ksm.yaml and see how to define one. Here, we define the name for the service within the marketplace. Then we tell KSM about the charts we want to use in this service offering, if it will be offered directly as a service or not, and the scope of each component's permissions. We see here that rabbitmq will be the direct service offering, while Prometheus will not, and Prometheus will have a cluster scope while rabbitmq will be limited to individual namespaces. Now here is our plans.yaml file. This is optional but highly recommended, as like PaaS tiles, KSM supports defining individual plans to ensure efficient resource utilization. Plans can be for things like CPU, RAM, and disk usage using t-shirt size names like small, medium, and large. Or in this case, we have two plans defined, one for an ephemeral instance of rabbitmq and one for a persistent instance. The plans.yaml file tells KSM in which files to look for these plan definitions, as well as the description to show in the marketplace. Finally, let's take a look at our deployment template. It's a pretty standard Kubernetes deployment template. Now, if we look in the CF marketplace, we can see there are currently no services being offered to our application developers via PaaS. Now we run KSM offer save with the arguments of the ksm.yaml file and the two chargez bundles. It reads the plans.yaml file to set up the plans, and now our offer is saved within KSM. Next, we need to run cf enable service access. This is a standard command if you are exposing a tile or a service through KSM. Okay, another look at the marketplace. There, now we have our rabbitmq service available as a service for our developers. Now, let's switch our point of view from the cluster operator who just made the service available to the application developer who wants to consume that service. Running cf apps, we get a list of the apps this developer has available on PaaS. We see here the app, My App. Let's take a look at the environment this app is running in. The details here aren't important to our demo, but what is important is to see that there are currently no vCap services bound to this application. Okay, now let's create a dedicated instance of rabbitmq to bind to our app. Cf create service is the standard command in PaaS to create a service, whether from a PaaS tile or from KSM. Now, let's take a look behind the scenes and see what's happening on our PKS Kubernetes cluster. Running git namespaces, we can see two kibosh namespaces created with unique IDs. The first is one that was created prior to this video, but the one below that is the one we just created. And taking a look within that namespace, we see our pending load balancer IP for our app to bind to. Again, KSM will handle all the credential passing. Developers will not need access to the PKS cluster. We're just showing what's happening behind the scenes. Back in front of the curtain, and our developer is going to check the status of the service. We see the create is still in progress. Let's give it a little bit longer. There, now our service has been created successfully. And now the monitoring application has come up and we can see that this service is up and healthy. Okay, now we can bind the service to our application, again using standard cf commands. Then restart our application for the changes to take effect. There we go, the application is restarted and the service is bound. Now, let's take another look at the application environment like we did before. And we can see that the vCap services has now been defined within our application. And we can see that the bind credentials are being stored securely within CredHub. So that's it. In just about 4 minutes, we were able to create our offering, deploy it in Kubernetes, and bind it to our PaaS application. So as we have seen, KSM allows platform operators the ability to extend their marketplace offerings with services deployed on Kubernetes. It also allows platform operators the ability to deploy those services from a variety of vendors and deploy them all at scale across all lines of business safely and securely. It also allows internal service developers a path to start offering their services to pivotal platform users, as we saw with the monitoring service being deployed with rabbitmq. And finally, it allows application developers the ability to create and bind services running on Kubernetes to their PaaS applications using the same commands as they use for PaaS tile services. Now, if you're looking to get started working with KSM and want to get hands-on, it's currently available as a tile in the Pivotal network. Here are the tile bundles as well as the local command line client. Installation instructions for each are available in the docs section, which we will link to in the video description. So that's all for now. Thank you for watching this overview of Container Services Manager for Pivotal Platform. We went over some of the problems KSM was built to help with, as well as the benefits to the primary user personas. If you have any questions, please feel free to reach out to your Pivotal representative, and thank you for joining.